Okay, let's go ahead and get started and get these out of the way and go ahead and move on to what we need to do today. Oh, go. I left that open. That's not good. It's all right. Yesterday, when you weren't here and I gave other people an opportunity to fix the back of their test, so if you weren't here and you need to fix yours, I'll let you today when I get done rambling. I do want to talk about the test for half a minute. Because there is a mistake that I've noticed on a lot of them. No, they're not completely graded, but there's this mistake I've noticed on a lot of them that I'm hoping you're going to correct before the next assessment. Because we do not want to keep making the same mistake. That's not good. Okay, so if we're looking at the test, yesterday I let people correct 17 and 18. Why? What have they done wrong? They didn't shade. I like this point. They didn't shade. So on 17, yes, you have to graph that line and you have to shade. But on 18, you have to do more than just that. On 18, I expect to see some work of how you rearrange the equation. Why is that? Because it's in standard form and we can't graph in standard form. Jack, get a point. Okay, if you had rearranged the equation, which some people didn't show them, I get you. Some people do math in their head, I do understand that. But if you didn't rearrange the equation and put it in y equals mx plus b, you wouldn't have graphed it correctly, and you also would have made another mistake. What's the other mistake you would have made? You had to flip the sign. Another point for you, Jax. You had to flip the sign because you divided by a negative. So if Jax had left it like this, he would have assumed less than and shaded below. He eventually, since he did math and showed his work, he realized that when he divided by a negative, it becomes a greater than, and he shades above. So now all of a sudden, Tylen's not only graphed the wrong thing, but she's also shaded the wrong region, all because she didn't rearrange this equation. Which, you're like, Ms. Compton, I understand that's a problem, but how does that correlate to what we're doing now? And I think it correlates directly because yesterday, every problem we were looking at was in standard form. So if we're not rearranging it to put it in y equals mx plus b, then how are we getting our graphs? Now, I'm not saying there's not a way you can go from standard form to a graph, because you can. It involves you remembering that trick about x and y intercepts, or maybe your teacher taught you a trick about negative b over 2a. There are lots of tricks to figure things out. However, most of us are not tricks people, we're old school, so I put it y equals mx plus b, I graph. You're not rearranging from standard to y equals mx plus b. You're really doing yourself a disservice, especially on yesterday's lesson where we could solve systems by graphing. You're not actually going to solve by graphing. Okay, and then the other thing that is concerning me is actually on me. So, one reason it's taken me a while to grade the test is because I made a mistake. Now, I'm going to pin it on someone else like you. It actually is a serious mistake. So, there are two different graphs, and I'm willing to accept on number 4. I wondered, so this is my first attempt, and I wondered why most people didn't match me. I mean, I graded all of first periods, and not one person had the same thing as me. And I was confused, because I was like, hey, I understand piecewise better than this, so why am I the only person with this graph? So I guess that's when I should have known I'd done something wrong. You know, I get in habits like you, not necessarily a good thing. I always assume, not going to assume, I always assume top is the line I need to do to the left of the fence. Bottom is the line I need to do to the right of the fence. And normally, that is the case. But also normally, it looks like number 3. And less than is on top and greater than is on bottom. So that's why less than negative 2 does make sense for left of the fence. Greater than negative 2 does make sense for right of the fence. So when it said greater than negative 1, I should have been to the right of the fence. Even though it was on top, they've tricked us. I don't know why they would do that on tests now and not before, but they tricked us. So here's the correct version with the green on the right of the fence and the blue on the left of the fence, even though green is on top. So my old diehard top is left, bottom is right. It's true if Miss Compton wrote it, because I like to put it less than on top, greater than on bottom. But we actually have to pay attention to that, because some weirdos out there put it in a reverse order. Like piecewise isn't hard enough. Now you have to pay even more attention. So if you have either of these two graphs on your paper, I'm giving you points for it. So that's another reason it's taking a little longer. Whew. Okay. Any questions about the test? Okay, good. Let's look at your math workshop. I should instantly have so many volunteers. Oh, Angel for the first one. 2. Square root of 4 is 2. Next. She gets a point for that. Yes, Paige.
9 square root of 3.
It is 9 square root of 3 because it's 81 times 3. The square root of 81 is 9, so 9 square root of 3. Paige gets a point. Next. Anyone new? Okay, Angel.
11 square root of 5.
11 square root of 5. 121 times 5. This one was hard, so I'm impressed you figured that one out. 121 times 5 is 11 square root of 5 because the square root of 121 is 11. So she gets a point for that. Number 10, yes, dear.
13 square root of 2.
13 square root of 2. It ends up being 169 times 2, which is 13 square roots of 2. And your group gets a point for that. 11, thankfully, someone new. Jax.
3 square root of 2.
For number 11 with square root of 150? No, you and I both know you want 25 somehow involved in that because 25 is going to go to 150. You want to fix it or you want me to let the girls save the day? I just did you. You. No, wait. We got someone new too. Anne-Marie. Okay, finally. Good, good. 5 square roots of 6. Okay, because it is 25 times 6. It's like I have 6 quarters to get to $1.50. And square root of 25 is 5, and 5 square roots is 6. Anne-Marie, your group gets a point. And then last but not least, I see these two, but you know this one's easy. Someone else can do this one besides these two girls, or they can just get all the points today. Anne-Marie. 2 square root of 6. Okay. Super happy with Anne-Marie, Paige, and Angel on that. And Anne-Marie, you get another point for that. Here's why. One, they had their bell ringers, they had their math workshops done in advance or something. Either that or they're freaking on it. Either way, I'm happy because we went through those quickly. Awesome. That makes my life so much easier. Not going to lie. The other reason I'm really happy with them has to do with next week.
There's a test on workshops.
There's a test on workshops when? Tuesday. So clearly those two, when they see the square simplifying radicals problems, they got that. They don't need to study that. They got that. They might need to study the factoring problems, and like I said, on Monday I'll be more specific about which word problems you might want to expect to reappear in your life. But they got those. They got the simplifying radicals down. That makes me happy, and that means they should get a good grade on that test, which is good because 60% category, last week of the 9 weeks, it's a big deal. Which leads me to my pitch yet again, because I say the same things every day to myself. If you've missed a test, I haven't even typed in the score from the test from Tuesday. So if you missed, so we hadn't even added in that lovely thing. So if you missed a test, you need to come see me as soon as possible. Next week is the end of the 9 weeks. And if you think I enjoy people coming at Wednesday, Thursday, Friday and stressing, I don't. It stresses me. I like my hair to be brown and not gray. Please get your life together and come see me before the end of next week. Come and see me as soon as you possibly can and get your life right. Okay, let's go to your packet. Bless your hearts. We just fly in here, and that's part of Altitude Treg. And again, we eventually do slow down, but part of the reason we can fly now is because this technically is review. Because you did learn graphing, substitution, and elimination in your Algebra 1 class. It's just been a long time. So I know we just discussed graphing yesterday, but we're moving on to substitution today, and lo and behold, we're doing elimination tomorrow. So if you've got a question, you want to ask it before we go to the next way to solve. Okay. Let's see. So, all that being said, I do want to go back over the 4 vocab terms we discussed yesterday. Can someone tell me the 4 terms from yesterday?
System of equations.
Ellie, you can steal it. Angel's going to get all the points today, we know.
Consistent, inconsistent, independent, dependent.
Okay, consistent, inconsistent, independent, dependent. Perfect. Those are the 4 terms you need to know on the next test. You need to know them not only because there's the vocab part, but most importantly, you need to know them because of these directions that we saw above number 1 yesterday. Not only did it say solve by graphing, it also said to get all your points tiling, you better describe it as consistent, independent, consistent, and the combos. Consistent, independent, consistent, dependent, or inconsistent. Okay, if you weren't here yesterday, you want to either ask a friend to copy notes, or you want to, of course, watch Google Classroom to get the video. The most important thing to me would be this chart that we made yesterday, because that helps me cheat. Like, if you're needing to study the vocab terms, that helps me think things through. If we have 2 lines and they cross, then we describe that as consistent and independent. If we have 2 lines and they're parallel, we describe that as inconsistent. And then if we have 2 lines and they cross everywhere, they're the same line, there's infinitely many solutions, and we say consistent because there is an answer, but we say dependent. And the reason that is because that answer is not special. So when they crossed at one spot, that answer was special. It was unique. That's why it's independent. It's special. But when they cross everywhere, there are so many different points where they meet. That's why it's dependent, because none of those are special. It's not like it's just one spot. It's every spot. Okay, so I'm hoping you're getting better with the vocab terms. We worked 4 examples, and life was great. We have a checkpoint on on graphing and substitution tomorrow. And the test on all this is next week. Okay, so today we're moving on from graphing, and we're going to substitution. Now, sadly, if I had my way in life, and I don't always do, if I had my way in life and I saw a problem set up like this, I would have never graphed to begin with. If it's in standard form, I wouldn't have graphed because it requires so much work. If it's in standard form, I wouldn't have done substitution either. I would have done elimination. But, sadly enough, as is life, you have to do what the problem tells you to. So if it says solve by graphing, by golly, you have to solve by graphing. And if it says solve by substitution, you have to solve by substitution. I think there are a couple where you get to choose. So, maybe Ryan hates substitution after today, and if he gets to choose, he'll never choose substitution. But if there's if it says it in the directions, he better solve it that way. Okay, someone who plays a sport, can you explain what a substitution is in a sport? Yes, Karen. Okay, you replace a player. Okay, and you take his position. Okay, and you can get a point for that, Karen. So that's what we're going to do today. We're going to take, if X is the quarterback, we're going to take him out of the game, and we're going to put in a replacement quarterback. It's not a big deal, but, if you're used to seeing the one quarterback and suddenly you see the new quarterback, it gets a little people confused. So our goal is to have one variable by itself. That's in one of the 2 equations, and that's the equation we're going to use to substitute with. Thankfully, number 1 is already set up for us. Which variable is already by itself? X. Ellie, you were first. Good point. X is already by himself. So in that second equation, it used to be 3x minus 2y equals negative 8. But I can replace x. X can be replaced with negative 5y plus 3. So everywhere in that second equation where I see x, I'm going to take x out of the game, and I'm going to put in his replacement, negative 5y plus 3. Are there any questions about that? Yes, dear. Okay, so we used to have x, and we've replaced x. His replacement was negative 5y plus 3. So everywhere we saw x, we put negative 5y plus 3. What's special about, and we're not done, I'm just circling its proof point. What's special about this long equation?
2y.
Notice that long equation only has y's. So if in your next step you've not eliminated or substituted out one variable, you've done something wrong. Our whole point was to get it with just y's or with just x's. Okay, and then from here you can solve. First period got mad at me. They said, Miss Compton, you went so fast over this part. Okay, we already took a test on solving equations. You already made it this far in life. Surely you can solve an equation pretty quickly. So if we distribute 3, we have negative 15y plus 9 minus 2y equals negative 8. If we combine like terms, negative 15, negative 2, we get negative 17y plus 9 equals negative 8. If we subtract 9 from both sides, we get negative 17y equals negative 17. And then at the very end, we have y equals what number? Just positive 1, because negative 17 divided by negative 17 ends up being positive 1. If you need to write more steps, you can. The good news is, if you normally struggle with solving an equation, math teachers tend to be nice. We tend to have pretty whole number answers for this section on substitution. So if Anne-Marie gets 1.25 or 1 1/4, she's probably done something wrong. In fact, I'm going to be so nice and advance on the test, if there are any decimal ones, I'll say, hey, P.S., number 5 is decimals, don't freak out. I'm going to be that nice. It tends to be pretty whole numbers on purpose. That way everyone knows you're on the right track because you did get the pretty whole number. You know some of us keep forgetting to combine like terms. So some of us aren't going to get negative 17. We're going to try to add 2 y's to the same side. I don't know why. It is what it is. Okay, and then Miss Compton was in a hurry, so I circled things and I wasn't done. Is that our answer? Aren't we supposed to get an ordered pair? Yeah, we should get like a set spot, because just like yesterday, we're trying to figure out exactly where these 2 lines cross. We're just trying to figure out where they cross without graphing them. I know that's stupid, but it's what we're doing. We're trying to figure out where they cross without graphing them. So we need to find the x value. So the good news is you can pick either equation you want. You can use the top one or you can use the bottom one. I think the top one would be easier, but if you want to plug it in the bottom one, you can. So our equation used to be x equals negative 5y plus 3. It used to be this, but you and I just found out that y, its value is 1. So everywhere I see y, I'm going to substitute in 1, and I end up getting x equals what number? Negative 2. So my answer is really the point negative 2, 1. So you're not done when you get just a y or just an x. Just like yesterday, you have to have an ordered pair, so you need an x and a y. Okay, now Tyler needs directions, and it didn't say she had to use vocab terms, but my gosh, we need to practice this anyway. What 2 vocab terms should I add to this number 1? We did find a spot where they cross. And I heard it from 1, 2, and 3. Get a point. Consistent and independent. They did cross, so we said consistent. They only crossed at one spot, that's why it's independent. You have to have both words. Okay, are there any questions about number 1 before I start talking number 2? Number 2 is not as nice. I wish it was, but it's not. Yeah, we are going to have to get one of the 2 variables by itself first. Number 1 was set up for us, x equals. Maybe in the future we'll have one that's already y equals. So this one we're going to have to rearrange. Which equation would be easier to rearrange? The bottom one. Paige, which one did you say?
X plus y.
Yes. So both of you can have a point. My God, y'all are today. The bottom one would be easier to rearrange. And since in the last problem we substituted in for x, in this problem I'm going to substitute in for y just because I want people to realize we can do either variable. So if I subtracted x from both sides, the bottom one would be y equals negative x minus 12. But again, if Daniel wants to be different, this one would be equally as easy to do x equals negative y minus 12. Doesn't matter. Okay, so I have a variable by itself. It's equal to this. So I'm taking out this quarterback, and everywhere in that top equation that I see y, I'm going to put in this quarterback instead. So my old equation used to be 2x minus 3y equals 6. But you and I just found out y is equal to negative x minus 12. So everywhere I see a y, I'm going to instead plug in negative x minus 12. So I've substituted in. Instead of y, I use his replacement, negative x minus 12. Are there any questions about that? Yes, dear.
Does it matter what one you do? X equals negative y minus 12?
No. You're going to end up with the exact same solution. No. The only thing people do weird, which I don't understand, is they'll solve for one variable in one equation and then try to plug it in that same equation. How does that make, like, you solved in one equation and you need to now plug it in the next equation. Okay, but again, I'm going to circle this one because I'm happy here. And I know we've done substitution right because this equation has only x's. So Elizabeth has made a mistake if she substituted in and she still has to deal with x's and y's. The whole point of substitution was to get rid of one of the variables. Okay, but from here we just solve like normal math. So 2x, I distribute my negative 3. Negative 3 times negative x, I get positive 3x. Negative 3 times negative 12, I get positive 36. I combine my like terms, and I'll have 5x plus 36 equal to 6. I subtract both sides by 30, and I get, I'm out of room, 5x equals negative 30. And so what does x equal? Positive or negative?
Negative.
Negative 6. Negative 30 divided by positive 5 should be negative 6. Okay, so we have a solution. We know the x value is negative 6. We've got to do something and figure out that y value. Is there anyone lost about how we got the x value of negative 6? Okay, well then from here, you can plug it into either equation. And you know, I'm lucky. Miss Brewster's with me first period. She plugged it into the equation we rearranged. So she did negative 6 minus 12, and she got the same answer I did. So you can plug it into any of them. I'm going to plug it into the bottom one before we rearranged it, just to prove a point. So it was x plus y equals negative 12. You and I just found out x is equal to negative 6. So I'm going to substitute in negative 6. I add 6 to both sides, and I end up getting y equals negative 6. So I had this equation. I substituted in negative 6. I added 6 to both sides. I get y equals negative 6. So my point is negative 6, negative 6. But again, if Jackson was to be different, let's say he plugged it into this green line, he would have had negative 6, which would have been positive 6, minus 12. He still would have gotten negative 6. It doesn't matter where he plugs it in at. If he's done his math correctly, he should get the same point regardless. Are there any questions about that? What words should I add? What vocab terms should I add? And page again. Get you another one. Okay, you're pretty smart. What's going to happen on the next page? Obviously more, but be specific. No, the homework's already listed on the board. My gosh. What's going to happen on our next 2 practice problems? Okay, how many different types of solutions are there? We've done a one solution. What haven't we done? we haven't done an inconsistent, which is the no solution one, and we haven't done the consistent and dependent, which is the infinitely many one. So we've got it. The next two are probably going to be those two. If I had to guess, I didn't even get to number 4 in first period because we were still behind from yesterday. But anyway, if I had to guess, what's going to happen? Okay, let's look at number 3 on the next page. Okay. I get that I am a math teacher, so obviously I like math. So I get that not everyone likes math, and maybe you don't see this, and that's okay. But I already know the answer just by seeing the problem on number 3. Does anyone else know the answer by seeing the problem on number 3?
Is it equal?
Is it consistent and dependent?
It is the infinitely many, and then what words for that?
Consistent and dependent.
That's going to be the words we end up choosing. How did I know that was going to eventually be our answer?
I think this is the like term.
What do you mean like terms?
They go in like the divisible by each other.
So they're multiples of one another. And so let's look at that bottom line specifically. That bottom line, and you don't have to write this if you don't want to. This is not substitution. This is extra. Okay, so the bottom line was negative 3y minus x equal to negative 6. But if we were to multiply that entire line by negative 3, we would get positive 9y, positive 3x, positive 18. What does that remind you of? It's the exact top line. So they really are multiples of one another. So since they're multiples of one another, they're the same line. And if you recognize that, and you can show me something like this, you don't have to do substitution, you don't have to do graphing, you don't have to do elimination. I don't care what the directions say. If you can recognize it and show me why you know the answer is what it is, you can stop. Because you know the answer and you're done. But if you don't see that, which is fine, because I get you're not a math teacher, it's fine. You're going to have to follow directions and use substitution. Okay, which line would be easier for substitution in this problem? The bottom one. So it would, in fact, there's a specific variable that would be easiest to solve for. What variable? X. So if it was negative 3y minus x equal to negative 6. If we add 3y to both sides, we'll have negative x equals 3y minus 6. If we divide by negative 1, we'll have x equals negative 3y plus 6. Now I'm ready to substitute because I have x all by himself. Are there any questions about that? Okay, well then my top line used to be 9y plus 3x equals 18. But you and I just found out x is actually equal to this. So I'm going to substitute in negative 3y plus x, negative 3y plus 6, good grief, for x. So everywhere I used to have x, I now have this, because x is equal to that. And that equals 18. And again, I'm happy at this step, and I know I'm on the right track, because our equation only has y's. So you know you're on the right track if you seriously are dealing with only one variable. Okay, so let's distribute. We'll have 9y minus 9y plus 18 equals 18. What's 9y minus 9y? So those two go away, and I just have 18 equal to 18. Is that a true statement? 18 is equal to 18, or 18 is not equal to 18? It is. So since we didn't get something crazy like 0 equal to 18, and everybody disappeared magically, that's how I know it's an infinitely many problem. Infinitely many solutions, just like we had guessed at the top, which is why we already put the words consistent and dependent, because we recognized this was going to happen. So if it's an infinitely many problem, all the variables will magically disappear, but you'll end up with something true, because this is a true statement. 18 is equal to 18. So what we assume is going to happen on the next one, all the variables will again disappear, but we'll end up with something crazy like 18 equal to 0, which is not true, so there's no solution. Any questions about number 3? I got some eyes. They need to put words.
The first one will be easier to solve.
Yes, agreed. Agreed.
And isn't our A our X and then the 3B would be like a Y? Or does it matter?
Yes, it doesn't matter. Doesn't matter at all. Okay, she's already on number 4. Let's go there. She said the top equation would be easier. Do y'all have 5 points? Okay, good. Let's just make sure. Because you've been on it. The top equation would be easier. It would be easiest to solve for A. It used to be A minus 3B equals negative 22. It would be easiest to get A by itself and have A equals 3B minus 22. Are there any questions about that? Well, then in our second equation, it used to be 4A plus 2B equal to negative 4. But we just found out you could substitute 3B minus 22 in for A. So we're going to have 3B minus 22 in for A. We'll still have the 2B. We'll still have the negative 4. All we've done is replace A with its substitute mate. Like, they were both quarterbacks, replacing A with his quarterback friend. Okay, if we keep going to distribute, we'll have 12B minus 88 plus 2B equals negative 4. And I'm sad because I was hoping just everything was going to just disappear, but I guess that'll happen in a minute. How sad. Thought it was going to be easy like the last one, and it's turned out a little harder. Oh well, I like math. 12 plus 2 is 14. So I have 14B minus, bless you, equals negative 4. If I add 88 to both sides, I have 14B equals 84. B equals 6. So, you know, I was banking on this one was going to be a no solution one, and it's looking like there is a solution. So I guess we did no solution ones in our examples today. Yay, I love it when other people besides me make notes. It's so great. So great. So I'm assuming life's going to work out holly jolly again. It was, I'm going to plug it in the top equation, but Justice can plug it in wherever he wants, really. B is equal to 6. So I should have A minus 3 times 6 equal to negative 22. So A minus 18 equal to negative 22. I add 18 to both sides and I get A equals negative 4. So darn it, I got an actual point. Which I know should make me happy, but I really wanted a no solution one. So we get negative 4 comma 6. Because A comes before B. And what vocab term should I put? And what? And get a point. But I'm sad because I really wanted an example with inconsistent. I really did. I am trying to in my head. How did you know that? I made one, but it's pretty easy, but it's worth a shot, right? Because we would like to see one with no solution. Okay, so if you got some free room somewhere in your paper, let's go to it. So I'm making up a problem. I'm going rogue. Whew! That's kind of scary. Let's say we had, and Angel's going to be mad because I'm making this super easy. Y equals x plus, oh god. Where are you, paper? Oh, okay, cool. Y equals x plus 4, which makes Angel mad. She doesn't even have to solve nothing. I'm already telling her who to substitute in for what. Yeah, I get that. My bad. I'm on the fly. And let's say the second equation is negative 2x plus 2y equals negative 10. Those are our two equations. Which one should I use with substitution?
The second one. I mean, you're going to sub in the first one.
You're going to sub in the first one because it's so easy. Yes, I phrased that question poorly. I understood that. Okay, so the first one's so easy. We already know y is equal to this. So everywhere in the second equation I see y, I'm going to plug in that. So yes, so I'll have negative 2x plus 2. Y is actually x plus 4. And that equals to negative 10. When I distribute, I get negative 2x plus 2x plus 8 equals negative 10. What do negative 2x plus 2x give you? So I end up with a crazy statement like 8 is equal to negative 10. Is 8 equal to negative 10? No, it never is. Don't allow it. So since we ended up getting something crazy, that's how we know there's going to be no solution. Which is what word? And Daniel gets another point. Gilberto, whoever it was, somebody in your group gets a point. Yay. So again, if all the variables go away, it's either going to be infinitely many or no solution. It just depends on if you have something crazy or something true. 18 equals 18? True. Infinitely many. 8 equals to negative 10? Not true. No solution. Are there any questions about these? Okay, well, you've been super duper good. You're probably, don't tell the, well, I should stop recording before I say all that. I'll say it anyway. They don't listen to your videos. You're probably my favorite class of the day. Not even gonna lie. You could go ahead and get your workbook work done. That would be smart. You could go ahead and start your checkpoint. That would be smart too. But as long as you're, yes, tomorrow. As long as you're not, I don't care.
It's tomorrow.